Hello, class. In this video, we will cover the solutions to Lab 4.1, 4.2. This is our first exploration of the quadratic function. So you're asked, is the function linear, exponential, or quadratic? How do you know? Well, the trick for quadratic functions, we're looking for the variable with the exponent that has 2, right? So I have x to the second, right? So anything that's raised to the second power is quadratic, assuming that the variable, the highest degree is a 2, right? So if I had x cubed plus x squared, that would not be a quadratic, right? The highest power or highest power exponent has to be a 2, okay? So since we have x squared, this is going to be quadratic, right? So for my explanation, because of the x squared term, quadratics are of the form ax squared plus bx plus c, and the value for a could not be 0, right? The second one is also quadratic because of the x squared term. Now, when we look at the number 2, well, this looks like y equals mx plus b, right? This is a linear function, right? Any function in the form of y equals mx plus b is linear. And then the last one, we call this exponential because the variable is in the power, right? This is 4 raised to a variable, right? See, here we had a variable raised to a number, variable raised to the number, that's fine. But here we have 4, or a number, raised to a variable. That makes it exponential, right? And the form of the equation is ab to the x, okay? So the b would be the 4. In this case, a would be 1 raised to the x. Next, okay, so here we have a quadratic function, and it says f is a quadratic function because of the x squared term. If you have an x squared term, and that's the highest degree, is a 2, we'll call it a parabola. If the coefficient of the x squared is positive, it opens up. If we had negative 4, it would open down. All right, so since a is 4, it's positive, so it opens up. The vertical intercept, well, when we have ax squared plus bx plus c, the c is your y-intercept, okay? If you forget that, you can always substitute, right? No matter what the equation, if we're trying to find the y-intercept, you can always substitute in 0 for x and solve for y. So this becomes 0 plus 0 minus 21. So when x is 0, y is minus 21, or negative 21. Right, so that's the vertical intercept. So when we graph this thing, we're going to cross the y-axis at 0, negative 21. Now, here's the formula for the axis of symmetry. Remember, the axis of symmetry is the imaginary dotted line that's going to split your parabola in half. Okay, so the a and the b, where does that come from? Well, if I take this equation, 4x squared plus 8x minus 21, I'm going to rewrite it and just show you. The a is the coefficient of the x squared term. The b is the coefficient of the linear term, or the x term. And c is the constant term. Okay? So in this case, a is 4, b is 8, c is negative 21. So the axis of symmetry says the x-coordinate of the imaginary dotted line that will split our parabola in half is given by negative b, so in this case, negative 8 over 2 times a. So my a is 4, so 2 times 4 is 8. So negative 8 over 8 is negative 1. So x equals negative 1. That's the equation for the axis of symmetry. All right, so again, what does that mean? I took the liberty of graphing this. If I were to draw an imaginary dotted line splitting this parabola in half, it would happen at x equals negative 1. Okay? And this is where the negative 1 comes from. Okay, now, the nice thing about the axis of symmetry is it helps us identify the minimum or maximum value of our parabola. So the minimum value is somewhere down here, and the imaginary dotted line splits, right? It helps us identify the minimum or maximum value, which is also called the vertex. So once I solve for the axis of symmetry, x equals negative 1, I can actually place x equals negative 1 into our original equation, right? Here's the original equation. If I substitute in negative 1 everywhere I see an x and solve, I get negative 25. So the vertex is negative 1, negative 25. So when I look at the graph, the vertex is the min or max value of your parabola. So here's my parabola. The minimum value is down here at -1, -25. Right? That came from this problem. Okay. The y-intercept is where we cross the y-axis, 0, -21. That came from question number 7. Okay. On a test, I am definitely going to ask these questions. Vertical intercept, axis of symmetry, vertex. These are guaranteed test 3 questions. Okay. So now we ask you to graph this with your calculator. So you already know that the minimum value is going to happen at -1, -25. So your window, y minimum, has to be lower than -25. So we use -30. Okay. So here's my window, and here is my my sketch. Now, how do we find the x-intercepts? Okay. Well, I'm going to open my calculator for that. Okay. So to find the x-intercepts, we're going to graph this 4x squared plus 8x minus 21. We're going to put that into our calculator. We have a window, -5 to 5, -30 to 6, and so on. I press graph. And remember, the x-intercepts are where do we cross the x-axis. So right now, you can actually press second, trace, and number 2 to find the zeros. But I think an easier way would be if I go back to y equals and I scroll down and press 0 for y2, that's going to give me a straight line at y equals 0. So watch what happens when I graph now. See how I now have 2 lines? I have a blue line and a red line. I want these intersections, right? The red line represents the x-axis, or the horizontal axis, and I want to know when does the curve intersect the horizontal axis. So I press second, trace, 5 for intersection, enter 3 times, and I get the point on the right, 1.5, 0. And notice that's what we wrote here, 1.5, 0. Now I need the second intersection. So now this is where we have to be careful. I press second, trace, number 5. This time I press enter only twice, because when it says guess, well, I already know this is 1.5. So if I don't want to press enter again, because it's going to show me 1.5 again. So I want to move my cursor to the other side, the point I don't know. Okay, so now my cursor's over here. Now when it says guess, I press enter, and I get, oops, I pressed it too many times, excuse me. Let me just fix that. I'm going to redo this. Second, trace, 5, enter, enter, and now when it says guess, I want to make sure my cursor is close to where I think the answer is. I press enter, and there we go, 3.5, 0. Oh, and it's negative. It's hard to see that, but there's a negative in front of the 3. Okay, so it's negative 3.5, 0. So those are my x-intercepts. Right, so it's important that you can find all of these points. The 2 x-intercepts, the y-intercept, the vertex. Okay? The domain of the function is all real numbers, right? So the value of x, this goes in the x negative direction and positive direction to infinity. So x can be any value, so the domain is all real numbers. But the range, y goes up to positive infinity, but y never gets any lower than -25, right? Because my parabola goes down to -25 and then goes back up. We never go below -25, so the value of y is greater than or equal to -25. Okay, I hope that helps. Thank you for watching.